Okay, so right now I am in StackCrunch, so you can go ahead and log in. So if you access my data and you go ahead and click on that, you should be able to access your first data file. And this is the class survey that I was working on in the week. So this is what we call, remember, our data sets. Our data set can be broken up into columns and rows. My rows are my observations, and my columns are my variables. In addition, we can break up my variables into two different kinds. So we had numerical and we also had categorical. So if you look at first generation, that's going to be a categorical variable because we can describe it as a label, whereas shoe size can be described as a numerical variable. Okay, so what we're going to do, if you look at our data set, it looks really difficult to see really what's going on, even though everything is really organized. So a best way to really look at our data and visualize our data is with graphs. Okay, so I'm gonna use this Word document that's also uploaded on Blackboard, so you can access it if you want. You can print it or you can follow along if you want. Okay, so the first thing that we're gonna talk about is going to be variables, okay, and how we can describe them. So I'm going to write variables here. Whoops, what happened? Okay, so I'm going to write down variables. Okay, so variables. And then I'm going to write down the two different types, what's numerical, okay, and the other one's what we call categorical. Okay, so the first thing to kind of know is what exactly is a distribution, because this is what a word that I'm going to use a lot. So a distribution is just basically a um, a way to visualize data. So a graphical way to visualize this type of data set. Okay, so first we're going to start off with a numerical variable. There's many different ways that we can describe the numerical data. I'm only going to talk about three different types of graphs. The first graph is what we call the dot plot. Okay, so the dot plot, each observation is represented by a dot. Okay, so if I look at this particular graph, I have a 1, a 2, a 3, a 4, and a 5. This is basically the patient satisfaction. So 1 means that they were not very satisfied with some particular service, and 5 was that they were very satisfied. And basically all it is, the y-axis here represents the number of dots that are in the in the in the data set, right? So in this case, the number of people that were not very satisfied was 2 people. That means that there's 2 dots there. So another way that we can call our number is also called the frequency. Okay, so this tells us how many dots are actually on the graph for each particular column. So here, 5 people were very, very satisfied. So this is a really good visual way to do it as opposed to just seeing it in one particular column in a data set. Okay, so this is what we call a dot plot. This is also used for small samples. Okay, so you can use it for big samples, but there's better ways to, what happened here? But there's better ways to really look at this. So small samples. Okay. Okay, so let me continue. Okay, so the stem plot. So a stem plot is a little bit different than a dot plot. The way that we write or draw a stem plot, you basically start off with the line. My left-hand side is what we're going to call the stem, okay? And the right-hand side is what we're gonna call my leaf. Okay, now my stem is represented by the number that's on the left. So in this case, since we have 2-digit numbers, we're going to look at the leftmost number, and in this case, it's going to be a 4, a 6, and continues on. So the lowest number that this data set comes up is with the 4, and the highest one is with the 9. Okay, so what I'm going to do on the stem side, I'm going to write down the 10th digits, which is 4, 6, oh, sorry, let me go back. 4, this goes away, I forgot the number 5, 6, 7, 8, and 9. Okay, I don't know why he keeps doing this, but I'll work with it. Okay, so we're going to start off with that, and then what we're going to do on the right-hand side, we are going to draw or write out the rightmost digit. So in this case, for 4, there's only one number, which in this case is going to be a 6. Okay, so I'm going to write down the number 6. Let me draw it in a different color. Okay, so this is going to be the number 6. Okay, now for 5, notice that there's no 50s in there, so that one's going to have nothing. For the 6, you're going to have a 67 and a 68, so I'm going to write 67 here and then a 68. For the 7s, okay, I'm going to have a 71, a 72, a 2, a 4, a 5, and a 7. Okay? A 7. Okay? All right, and then for the 80s, I'm going to have an 81, an 84, an 85, an 89, and that's it. Okay, and then the last one, I'm going to have a 93, a 94, and a 95. Now, a couple things to note. Notice that I wrote 2 2s here because there was 2 72s. Okay, so make sure that you always include if there's repetitions. Okay, and if you kind of tilt your head over to the right-hand side, you can kind of see that this is kind of the distribution of this data set. So you can kind of see it kind of visually. You just kind of have to tilt your head a little bit, and that's basically what a stem plot is. Okay. Now, usually you have 2 different types of stems, and I'll show you when we're using StatCrunch, but sometimes there's a lot of numbers in the 70s, so you might want to break it down from to 2 different 7s. So I'll show you that in StatCrunch, but this is basically the basis of a stem plot. Okay. Now, the last one, which is the one that we use the most, is called the histogram. So a histogram is grouped into bins, and the bars are drawn to show how many observations you have. So in this case, my x-axis is the number of shoes. So the number of shoes that my students own. You can see that from 0 to 10 shoes, okay? So how many people own from 0 to 10 shoes? Well, the height of this bar will tell me how many that is, and approximately this is going to be 18. So 18 people own between 0 to 10 shoes. And you can see that it tends to decrease as the number of shoes tends to increase. Okay, so this is basically a way that you can represent it. Another way that you can do it is using relative frequency. Okay, so relative frequency, notice that the graph looks exactly the same. The number of shoes is exactly the same, but what's different is that now this is in terms of decimals. So basically all you just did was you just take the frequency, so how many people there are, and divide it by the total. Okay, so the total in this case, I believe, was 53. So if you put 18 divided by 53, you should be able to get about 33%, and that's why this is 0.33. Okay, so what I did is 18 divided by 53, and this will give you approximately 33% or 0.33. Okay, so that's basically how you can visualize your numerical data. You can have these 3 different types of graphs. Okay, so in the next video, I will give you an example.